Alright, today I'm going to test some low pass filters. These are both the 30 megahertz variety. So we'll test this smaller one first. You can find these a lot on eBay and places like that. They seem to be pretty well stocked on eBay. There's a lot of them, I guess, in surplus from the older days of, analog television and stuff like that. I think these were important for HF and CB transmitters and stuff back in the older days, and still they can be pretty important even in today. So this one is good for a kilowatt. We're not going to worry about trying to figure out the power. It says it's about a 52 ohm device, so RL Drake should be about 80 dB attenuation above 41 megahertz. So I have my tracking generator on. You can see I got this big hunk of like RG LMR 400 equivalent or something there, so it's a pretty substantial cable. We got it normalized so that we're sitting at 0 dB, and we're starting at a center frequency of 30 megahertz right here. So when I put the filter in line, we should be able to see the roll off effect of it. So I'll get the filter in line and then I'll be right back. Alright, so the filter's in line. This is your transmitting side of the tracking generator. This is the antenna side, so you're basically sending out the device, going through the filter, coming back around, going back in, registering. So this is supposed to be, 80 dB below at 41 meg. I'm kind of holding it. Let me get something to prop this up because I don't like this leaning. Although it's just leaning on the connector. It's not pulling on the end. I don't want to damage the machine, but I think it's going to be okay. So let's go to peak and we'll roll around up here. You can see the frequencies. There's really no filtering at all there, so that's normal because it's a low pass, so all this stuff is going to pass through no problem. Once we get around 30, around in here, we start to see a little bit of attenuation and then a little bit of dip up. Then at right about, this is about 41 megahertz, so right at about 34 or so, that's when it starts to take that long dive down. And what are they saying here at about 41? Yeah, so I'd say that's fairly accurate. About 70 dB down, so that filter works. If you have problems with some type of transmitter or something causing spurious emissions above 40 megahertz, this is your guy to fix that. Let's kind of span out a little bit. Generally, these filters kind of at a certain point stop filtering. This tracking generator and spectrum analyzer will go out into the gigahertz. So I'm assuming that eventually there's 1 gig there span, so stopping at 1 gig, so not too bad. A little bit of some stuff populating now. Even this line here is minus 27, so obviously at 3.2 in this range, obviously we're going to see a little less attenuation, but I don't think we'd ever have a concern to be worrying about. If we're transmitting below 30 megahertz, it's a very unlikely situation where you'd ever cause interference into the microwave frequencies. And even then, this filter is still filtering, I guess, at, what is it? If we come way over here, just a little bit above minus 27 or something, that is worse, to minus 17.8. So, and then right around it's for some reason it struggles around this 2.3 2.4 gig range, and then it kind of settles down around here and goes back, and then it kind of comes back up. So anything I would say below 2 gigs is perfect for this filter. So it's working just how it's designed, and everything else is little to nothing. So alright, so the next one we're going to check is this bigger one. This one says 70 dB of attenuation above 32 megahertz. And this one can handle apparently 6 kilowatts PEP, so never will find that out or not, because I never would have a amplifier or anything capable of putting that kind of power through this filter. But I guess this is heavy duty. Maybe this was made to go on a tower or something. You see a grounding lug there. So it's a pretty heavy piece of gear here. So let's find out how this one works. Alright, so one thing I should have done probably if I was going to take measurements out into the gigahertz on this filter, which I didn't do, is initially I should have normalized the tracking generator for those higher frequencies. So very likely that we may not have seen such a drastic, loss of filtering there, attenuation. I can't guarantee that, and I don't really want to get into that. The goal of these is more for the, we're worrying more about 32 megahertz and up. So we get into those fundamental frequencies. I mean, that's going to be many harmonics before we get to up into the gigahertz range. I don't think that, a transmitter 30 megahertz or below is going to severely affect those high frequencies. But I mean, that's something I could do maybe later or something just for fun, just to check it. And what I would do is set my frequency up into the gig range, and then I would normalize, because watch what happens if I go up, let's say 2 gigahertz, 2 gig. So you can see it's not ideally perfect there. It doesn't really look that bad, but I would go to tracking generator, turn that off, I would store reference, and I would normalize. And then obviously now we're telling it that this is what we want to see. Basically no loss, just a straight line. So we could test a filter like that in these higher frequencies and probably get a better idea of what it's what it's going to do. Would it change? Maybe a little on what we're going to see, but probably not very much to really care. And again, these wouldn't really be for those high frequencies anyways. You can kind of expect that at a certain point the filter is going to run out of real estate, and it is going to lose some of its ability to filter way beyond what you would need anyway. So we're not going to worry about that too much. But I'm going to go back to center frequency 30 megahertz, and I'm going to span to, let's say, just for the heck of it, 500 megahertz span. So that way we can get a pretty broad range on this big low pass filter here. So I'm going to go back and store my reference and normalize, and now we're good to go. So I'm just going to hook this one up. This is a pretty heavy one, so I'm going to try to prop something up under here. That way it's not leaning down so much. Alright, so we'll rest it kind of on this HF transceiver here, like that. That way it's got something to kind of brace itself against. And let's go over here. You can see that sharp roll off up here. Let me get this over here so we can see the frequency as I scroll that marker 1. Obviously there's really no attenuation anywhere around there until we get to, what does this one say again? 32 megahertz is where it starts to really fall off. And you can see it's starting to fall off there, and it slowly dips down. And it's saying 70 dB. So let's see where it hits 70 dB. Probably more like it's going to be really tricky. I don't really ever see 70 dB out of it, although there is a really sharp decline. I'm not really seeing the full 70 dB. That could just be a little overstatement on the company here that designed this, or it's just a little inaccuracy from the test here, which very well could be too. But this one still has a very sharp drop off. Let me span this back to like 100 megahertz. Then we'll go center frequency 30. Whoops. There's another view of it here, just to take a look at it. We can come out and see when it pretty much drops off and slowly climbs down and basically just falls off into the noise. There's about 70 or something there. So I would say this one is more like about 40 some megahertz before you get that full 70 dB of attenuation like they say. Although, I mean, when you're talking like in here, it's such a, whatever you're putting out for power, just realize that you're attenuating it by like 50 dB at like 41 megahertz. So it's not really anything to worry about that it's not dropping right at 30, whatever it says, 32 megahertz. You know, it's going to have a sharp decline like all these filters do before you get down to where it should be at. So, I mean, it works well. And for a high power situation, this I guess would be the filter to go with. Would I ever have a high power situation to run this in the amateur radio or any other radio hobby? Definitely not. So for me, it wouldn't be anything I could benefit from, but maybe somebody could. And if anyone's interested in this filter, whoops, I totally just screwed that up. Drop me an email on my QRZ page, which you can look me up with the name of my channel, with my amateur radio call sign. If someone's interested in this for a high power situation, I'd be more than happy to pass it on, because I have no use for it for its 6 kilowatts power handling. But obviously, you know, you're putting 6 kilowatts out, it's definitely gonna, if there's any spurious natured stuff after 30 plus megahertz, it's gonna work. So personally, for me, these probably would be a better suited thing for me, because you know, if I was worried about some many issues above, you know, on this situation 40 megahertz or something, that one would be the one I would go with, just because I've never even run a kilowatt normally, so it would work well. But if someone is interested in a high power scenario, this would be the filter for you. Let me just put my little scale up here, and just to give you an idea, this thing's got some weight to it. All right, well, I guess we can't do the scale because my wife has it. So one more bonus filter we'll test here. These are bandpass filters, so a little bit different design on these. These are going to have a sharp roll off after the filter passband and before the filter passband, and you're going to have a passband on both sides. So obviously these frequencies will pass no problem, and then it should start to roll off as we get past the CB band and also before the CB band. So that's what we're going to look for there. So it's not really necessary to renormalize, but I'll just do it for this situation just because. So we'll go to the CB band right in the middle. I've already tested this one and found that the test that I see here on my spectrum analyzer pretty much matches up with what this manufacturer, Morgan System, shows on their website. So it's pretty fantastic that I can duplicate what they show, which I think is really cool. So we'll go here and here and here. Okay, so we've pretty much normalized now. Let's actually span this out to 100 megahertz instead, and that should give us a good sharp view of what this filter is capable of doing. So there we go, that's better. So I'm going to hook this one up. These are pretty light. These can only handle 200 watts. The radio side will go here because this is going to be our RF, and then we'll hook our antenna side up, which will go into the device. All right, so there's our bandpass filter roll off, and literally that picture looks identical to the picture on Morgan Systems website. It's a little tricky to see unless you bring it up on a computer, but I was able to see it on my phone, and it literally mimics exactly what they're showing. So you can see there's a gigantic dip right here, literally, whoops, which literally, let me go here, which literally drops this down into the minus almost 70 range, which is crazy at 65 megahertz. So let's just say, for instance, that for some reason your CB radio with a power output of up to 200 watts, now I can't guarantee it, I'd have to call and ask them, what is this rated at, peak envelope power, or is this average RMS? It's probably peak envelope power. So let's just assume that somebody's transmitting with the CB radio and they're causing massive interference for some reason in the 60 megahertz range, which I don't even really know what's used there. I'm sure there's some type of, the FCC in America has probably sold that frequency bandwidth to somebody, some business or something. Or let's say that you're getting interference in your radio and you've tracked it down to like these frequencies, this will eliminate it. You wouldn't hear anything in your receiver. So it can work both ways. As you can see here, if we go, you know, like this, some of the CB channels are in here for the second harmonic. They're already down like minus 30 some dB. Now, usually a CB radio or something is going to have a low second harmonic anyways. So just imagine that, let's say it's already 30 dB down. Well, with this, you've probably already added another 30 dB to it. So, you know, the filter would really help there. Normally, those second harmonics are really low on a CB. But I guess if you're running some type of bad amplifier or something there, then it may change. But so you can see here, as we get closer to the CB band, it really, you know, the roll off is less. So I would like to see a little more sharp roll off, but I think maybe that's just the design of this one. They do make another one that is a different style bandpass filter, and it does say it has a little more aggressive roll off, and that's probably one that if you were having problems, and say for instance that somebody was running like I don't know, like say for instance you're on your CB and you have an amateur radio operator down the street running 10 meter, he probably could interfere with you, especially if he was running a high level of power, just based on the simple fact that you're so close. You know, this may not help you in that regard because it's not giving you much separation there. If you were seeing it like in this range, then probably it would be better. So they do make a different kind of filter for the CB band that probably would give you a little bit more sharp decline, more attenuation, closer to, you know, the CB band. We can see here that, you know, it really doesn't start to drop off here until somewhere, you know, almost in the 17 meter range or something even after that. So not as good of decline on the lower side either. So maybe it's not really the best, but it will knock out interference from, let's say, like high frequency problems. You know, I don't know if like fluorescent light interference could be affected with this filter. Maybe it would help. I have another one here too, the same one. They both test the same. If you're getting interference from fluorescent lights or something, it would just depend on what frequency that RFI is coming from. These filters might help with that and help knock some of that noise out. So it's not going to really affect your TX really much at all. We're not seeing much of anything really here. Maybe a half a dB or something, which really isn't that much to worry about. It's more for, you know, this would be more for like helping the receiver kind of knock out some noise. And you could probably run a combination of both. You could probably run one of these with the radio after the radio, and then you could run, let's say, where's that other one, that big one that I had, where I can't remember where I put it, so we'll just grab this one. If you were running an amplifier, let's say, you could put this after the amplifier, and that would really cut down on you causing interference and also you receiving interference from higher frequencies in that regard, because the low pass is going to severely cut in this range way down, plus with this one adding in. It'd be interesting to see that as well, and maybe I can do that really quick. Let's just see, because I'm curious to see what it would do if I added that low pass right here. How is that going to change? I imagine all this is just going to drop. Alright, so now we have our low pass and our band pass. So as you can see, just like I thought, a huge drop. So the low pass is working, the band pass is working. So kind of interesting. As you can see here, there's our band pass band here, TX. So it looks like it's good with the low pass in there, at least from 30 to 25. Even probably 12 meter, it's going to drop off a little bit there, maybe a dB or so, which really wouldn't hurt you. But once you get past 12 meter, obviously the band pass is working, and it's lowering down even on 15 meter. If someone was interfering with you on your CB radio around 15 meter, which is probably highly unlikely anyways, you would, 13 dB down. So they'd have to be running some really bad HF equipment or something, or a really poorly designed amplifier. And usually that's not the case with ham radio people, amateur radio operators interfering with the CB. Usually it's the other way around. So obviously now with the low pass, we can see basically after about 35, right around here, 34, 35 megahertz, it just slowly drops to nothing. And then around like the 40 megahertz range or whatever, we have nothing. So, this would be probably, if you really were concerned as a CB operator of being cautious with what you're transmitting with, this would be the way to go. Run the bandpass off the back of your radio. And these come in all different power configurations. I've seen them as high as a kilowatt or more. Maybe not for the CB band, but for like, let's say 10 meter or any of the other HF bands, they have high power bandpass that you can get. But since we're just kind of using the CB analogy here, since that's what this one's designed for, let's just say that you have a 2000 watt bandpass filter for CB. You would probably, depending on what you wanted to do, you could run it after the amplifier, I guess. If the amplifier can, let's say, put a kilowatt in and you put this after it, and it's a 2 kilowatt filter, it's going to filter everything after that. And then probably just run this right off the back of it. If this could handle, let's say, 2 kilowatt, which this doesn't, but you would need that other one, the bigger one. And then basically you're covered both ways. You're covered as far as filtering anything that said dirty amplifier might be producing that could negatively affect the ham radio community going in HF, and also going forward into 10 meter and everything beyond 6 meter, and just keeps going forward. I'm not saying that someone should run out and buy a huge amplifier for CB, but I mean, we already know what people are doing, and it doesn't mean that they're not doing the same thing on ham radio and on HF, because just because there's power limitations, it doesn't mean people follow it. Some people enjoy running high amounts of power, and it's just what it is. So, having filters that can be capable of handling the power that you want to throw out there in the RF spectrum, I guess, it's a tool, it's helpful. Not everybody really will find this video interesting, but I find this stuff interesting. It's a fun test to do. Would I use this with my CB? Yeah, absolutely. I bought 2 of them, one for my car, one for my house. When I get my Mosley HF antenna up, I plan on just having like a dedicated radio for my house for CB, and I can show you guys what I'm thinking about using. So it's probably going to be this. This is a new old stock that I've never used. I've never even taken it out of the box. I opened it once just to look in. You could tell it looked brand new. I'm kind of I enjoy the older radios for CB. I have this Grant LT here that I enjoy. That one is also a new old stock. I've taken it out of the box once. I think I never even hooked it up. I just looked at it. So both of those were new old stock from the same person. I found it on Craigslist, if you believe that, from Wisconsin. So I took a chance, but I was lucky. So that's probably the Washington is the one I would run for CB. Otherwise, I have this base station here, this Pro 810E. I really like that one too. I need to put that one on my bench and just maybe realign it just a hair, but otherwise it works perfect. So it'd be one of those two. This Navajo, I enjoy this one. It does need a little more work. I need to put it back on the bench and have some time on with the bench with the equipment to kind of go through this one more. But it is in pretty nice condition, and I'm not super attached to it, but it's just finding the time. I really enjoy that classic look of that radio also. It's very nostalgic in its own way. So this one, it works, but I think there's an issue with the power supply going out. One day the power supply will work, the other day the 12 volt will work, and some days it's vice versa. So there's definitely something going on, and I need to figure that out and find a remedy to it. But we're getting a little off topic here. The topic was that low pass filter. So yes, the bandpass. I would run the bandpass on a dedicated CB setup. and I'm not worried about running any extra power or anything like that. So the bandpass would work great with one of these radios. So probably what I'll do, since this is already out, I will put this my antenna switch here. This is a vertically polarized antenna for my antenna on the tower. That's going to come down anyways, but I might just switch that right over to the back of there, take that double male, plug it in the back, and there's my bandpass filter for CB. I can sit and talk local or whatever on this when I want to, and just kind of enjoy the classic radio. But that's pretty much it for the video. Hope I didn't bore everybody to death. I find that, you know, the filter testing is fun. I may not be perfect at doing it, but I find the results are fairly accurate from what I'm seeing. So again, if you like the video, please give it a like, a thumbs up, and please think about subscribing. It really helped me out with my small channel that I'm starting here. Some of you guys are coming over from my Scott's Radios channel, and that's really cool. I just enjoy doing this kind of stuff in my free time, testing filters, testing radios. I generally don't do anything with older radios for any of the clients or anything through my small business. I just kind of do it for myself, because some of these radios are very hard to come by, and you know, I don't have parts radios or any of that stuff laying around here. So if I can't fix it, it generally just gets pushed to the side for my own whatever reason, because I don't have time. So if I can fix it, I really enjoy doing that stuff. And a lot of times the old radios are just out of alignment. People get in there and start turning stuff because everybody wanted more power and they don't know what they're turning, and we all know what happens, you know. And those radios from the 80s and 90s and the CB heyday back then, it was always about extra power and whatever you could do to it. So in a lot of cases, some of the older radios, maybe some of the electrolytics might be wearing out, and that could be the case with that Navajo. That could be all it is. Maybe there's filter capacitors going out in the power supply section, and one day it works, the next day it doesn't. So sometimes you never know. So anyways, thanks for watching, and hope you enjoyed the video on the filters here. 73.